Good afternoon, ladies and gentlemen. My name is Tim Ports. I'm the executive editor of Biomass Magazine. Tickled to have everybody with us today as we talk about anaerobic digestion, the common pitfalls with that technology, and strategies to overcome them. Today's webinar is sponsored by CAT, and we are very honored to have two members of their team as presenters on today's call. The title of today's webinar, as I talked about just a moment ago, Biogas to Energy Project Success, Overcoming Common Pitfalls. Anaerobic digestion is a technology that holds incredible promise. It's a very active part of the greater biomass industry right now. A lot of development, a lot of excitement around that particular technology. It's a challenging technology to deploy, however, because not only is it a mechanical system that has to be operated and has to be operated efficiently and well, it's of course also a biological system. And that aspect of the digester needs to be managed and needs to perform so that yields are maximized. Before I hand it off to today's first speaker, I want to talk briefly about a couple of housekeeping items. The GoToWebinar platform is a great portal that allows all of you, our listeners, to submit questions to today's panelists, and I invite you to do that. While I cannot guarantee that every question will be answered, we've worked with all of the panelists on the platform, and any questions that they can get at and make time for, they certainly are going to try that. Additionally, I will be saving a few of the questions that I receive that I think have some broad appeal for a question and answer session at the conclusion of all of today's presentation. So please do that. We are recording today's webinar, and that is how we make these presentations available for further review after the fact. I also want to direct folks' attention to the GoToWebinar screen. At the top right-hand corner of the screen, there's a little icon. It's a camera. If there's a particular slide that you just feel like you absolutely have to have right now, if you actually click on that icon, that will do a screen capture of that slide. So I want to make people aware of that. Certainly forward your questions. The one question request I would make of your questions is that you identify which panelist the question is for. So if you have a question for Ben at the conclusion of his presentation here, simply put Ben before your question, and I will make sure that that question gets directed to Ben upon the conclusion of his remarks. If you have a question for everybody, simply put all in there, and we will certainly put that on the list of questions to ask at the conclusion. We've got three presenters this afternoon. Ben Matthews joins us from Caterpillar Electric Power Gas. He's going to give us a broad overview of Caterpillar's technology and how it's deployed. Paul Owen from the Cat Power Finance team will follow Ben and look forward to understanding how these particular projects are financed and how to circumnavigate some of those financial pitfalls that digestion projects sometimes run into. And then the presentations will be concluded today with some comments and a presentation from Ross Buckingham, CEO of California Bioenergy. So I look forward to today's presentation. Again, thank you all for being here. Thank you for CAT for making this possible for us today to bring this to you all at no charge. And with that, I would like to introduce our first speaker, first presenter for today's webinar. Again, his name is Ben Matthews, and Ben comes to us from the Caterpillar Electric Power Gas organization. Ben, looking forward to your remarks.
All right, thanks, Tim. And as Tim mentioned, I'm with Caterpillar's Electric Power Gas Group, territory manager for Western United States and Western Canada. So what I want to discuss today is first give a brief background of Caterpillar in the biogas and electric power gas space, as well as some of our experiences, and then go into more specifics on considerations for engine generator sets, going from strategies for dealing with contaminants, trade-offs between buildings and enclosures, additional kind of operation and maintenance considerations, and then to close out with kind of the importance of availability to a biogas application. So just to get started, Caterpillar supports a wide variety of customers in the electric power gas space. This illustration kind of shows who some of those customers or what some of those market segments are. So just as an example, going from left to right, we could provide combined heat and power to district energy, district heating plants, biogas generator sets to landfills, complete combined heat and power solutions to greenhouses where they not only use the heat but also the CO2 from the exhaust, provide natural gas standby units to both commercial government facilities as well as industrial manufacturing plants, standby electric power, gas, or CHP in those applications. We provide biogas CHP to wastewater treatment plants, ag, food processing plants, coal mine methane projects, and as well distributed generation to electric utilities. So just kind of a brief background of the different segments that we're involved with. And we have a considerable amount of experience, in the marketplace. So the picture above kind of represents our installed base, from a 15-year span. We've shipped roughly 17 gigawatts worth of electric power gas product over the last 10 years, and we have almost 50,000 engines shipped, installed, with close to 5 billion operating hours. So specific to biogas, we installed our first units in the early 80s, mostly initially to landfill sites, and since then we've installed about 1.5 gigawatts of biogas product worldwide. And just kind of a frame of reference, that's well more than 1,500 units installed on biogas with about 50 million hours of operation. So we have experience with harsh landfill gas applications, experience with many types of digesters, lagoon, plug flow, complete mix, experience with a wide range of feedstocks, and as Paul will mention later, we also provide project financing. So in the biogas space, we have a full line of product offering, from 50 kW to close to 4 megawatts on biogas. And of that, we can provide from the bare genset to a complete CHP enclosed solution. So that's just kind of a brief background to Caterpillar. What I want to do now is kind of go through engine generator set selection criteria and what we look for. So first, I want to talk about strategies for dealing with contaminants. And before doing so, I want to show what a couple of the contaminants are and their impact on the engine. The first, hydrogen sulfide, or known as also H2S, does cause problems when it corrodes and, excuse me, I need a quick drink. When it condenses with water, it creates sulfuric acid and can cause problems. So the illustration on this page shows a warm after cooler core that doesn't condense with H2S, or where the H2S does not condense with sulfuric acid, and then the other is what happens when it corrodes. Excuse me. So another problem is siloxanes that we see primarily in landfill gas or wastewater treatment plants. So siloxanes cause abrasive wear and build up deposits inside the combustion chamber. So you can see a couple examples. On the left is exhaust valves with significant siloxane buildup, and if that continues to happen and the valve is not able to close all the way, it creates what we call valve guttering. So another impact that siloxanes have on is contaminants on like spark plugs. It can plug spark plugs, create misfires, and you have to kind of be aware of what type of technology, engine technology you're using, spark plugs you're using, and how it handles the wear from that. So that's just kind of a brief overview of the couple of different types of contaminants, and I guess getting into the specifics, there are different strategies for dealing with contaminants, and you have to kind of weigh the pros and cons of, you know, different engine technologies, fuel treatment technologies, and analyze both kind of the initial capital cost and what your long-term costs are. So the first strategy I want to talk about is pretreatment, or cleaning the gas to natural gas quality. You know, this pretreatment does cause a significant impact to your capital costs, and as you scale down in size, that impact is much larger. So it's just something to be aware of with pretreatment. In some instances, especially around in the U.S. and where local air board requirements will require after treatment, you know, pretreatment is required regardless. After treatment, such as SCRs, oxidation catalysts, etc., they cannot handle the hydrogen sulfide that's in the gas or sulfuric acid. It will poison the after treatment, you know, components very quickly. But an advantage of treating the gas, cleaning the gas, is you do have more predictable maintenance intervals. The biggest, you know, because it's a consistent gas, high quality, you can hit kind of expected spark plug, oil change, top end overhaul type of intervals. And also with a high efficiency, or with treated gas, clean biogas, you can utilize high efficiency engines which have less of a margin for, you know, contaminants. So the other strategy that we have for dealing with contaminants is basically hardening the engine or fortifying the engine. So this is something we see a lot of times in North America, because in North America we're competing against very aggressive utility prices, and there's not a large margin or a large gap for your power purchase agreements. And so a hardened engine, you know, you do have a lower capital cost up front because you're not investing in as much cleanup equipment, but you do see some increased intervals. So there is a trade-off, and it has to be evaluated. Just to kind of give you an idea of what Caterpillar does to, I guess, harden the engine for biogas type applications. First thing is we replace bright metals with stainless steel. Basically anything that could come in contact with condensed H2S, we replace that with stainless steel. So the example on the left-hand side is the aftercooler core, where I showed kind of the two sides of the clean side versus the corroded side. Well, in a biogas engine, the aftercooler core is stainless steel. Another thing we do is we elevate the jacket water temperatures and basically raise the jacket water temperatures inside the engine to keep it from condensing and keep water that would normally be in the fuel going through the engine. If it's elevated enough of a temperature, it won't condense and won't, I guess, impact the internal components of the engine. The picture there in the middle of the screen shows what a corroded liner would look like if without elevated jacket water temperatures. And then for siloxanes, we optimize the valve design to deal with that kind of abrasive components or the abrasive material that would go collect onto the valves. We have a valve, we adjust the valve angle and valve seat so that as it builds up, the valves will continue to close and to keep from that guttering valve from happening. So that's kind of just a quick overview of what we do to deal with contaminants. The next I want to talk about briefly is kind of some trade-offs between buildings and enclosures. We get this quite a bit, especially with biogas and anaerobic digester applications, is kind of which direction should we look at. In general, a building is recommended wherever possible, wherever it can make sense, I guess, financially. It provides the optimum environment for service. You have plenty of room to work. In a building installation, you'd have plenty of room to work around the engine. You're not exposed to the environment. So if you're working in northern Canada or somewhere where it's less than ideal, you would at least be sheltered from the environment. And all in all, a building just increases your total uptime, availability, and is a preferred solution when it can make sense financially. An enclosed solution is also an alternative. It's also an enclosed solution is a lower capex than a building. The general rule of thumb is if it's 2 units or less, enclosure makes the most sense capital-wise. Once you get to 3, 4, or 5, building starts making more sense. You do have reduced engineering procurement consultant costs if you go with an enclosed solution versus a building. And the turnaround from order to delivered and producing power is quicker with an enclosure because everything leaves the factory prefabbed. Another topic I want to go through is what are some of the additional operation and maintenance considerations to look at. And the first one is what I see most of the time, and is how much load do we need to be putting on the engine? Well, gas engines like to be loaded to 100% if possible. They're designed to run at 100% load factor 100% of the time. As you go down in load, whether the digester is still creating or building up its gas supply, or the digester is not producing the level of biogas that was anticipated, you start to run into issues. General rule of thumb is to size for greater than 85% load. Most engines and engine manufacturers have a limit or a minimum of load that a gas engine can see. It's usually around 50% load, but even if it's seeing 50% load, it needs to see 75, 80% load at some time just to burn out the oil that's in the combustion and all that kind of stuff. overhead lifting capacity is a must. I've seen many sites that without like an overhead crane or something to help in the service. You know, cylinder heads for a G3520, for example, are between 100 and 120 pounds. And if you're doing a top-end overhaul on that type of product without lifting capacity, you know, you have to increase your labor, number of people, as well as the time to make that service happen. Also, you know, best practices we've seen, operator definitely increases your uptime. I know not all projects can afford to have a full-time operator just due to the size of the project, but when possible, you know, that makes a big difference. And then also, predictive maintenance strategy is very important. And what I mean by that is basically monitor everything. So valve recession, the blow-by, oil consumption, fuel consumption, exhaust emissions, you know, trend. By looking at these different components of the engine, you can see, I guess, how the engine is wearing and when it's time to do the kind of the major maintenance intervals, and you know, repair before failure. So a lot of times, if you repair after failure, you know, you pick up some collateral damage when the engine fails. So it's important to have a good strategy in place, and you know, it's a good predictive maintenance plan can reduce your total operation maintenance costs by more than 15%. So it's not insignificant. And then the last point I want to touch on is the importance of availability. A lot of times when projects are in the feasibility or development stage, you know, emphasis is placed squarely on electrical efficiency, but I think availability often gets overlooked. And what I mean by availability is it's the revenue lost anytime the generator set is not operating. So during maintenance and repairs, or when, you know, fuel supply is reduced and interrupted, the main part I'll talk about here is kind of how we can control availability is, you know, minimizing the engine downtime. So just kind of a quick look at what availability, how that impacts the bottom line is, you know, just taking two identical projects at a sample size, so a 1,000 kW unit, you see a 6% difference in availability. So an engine that's available 6% more of the time has, you know, over a 6% revenue advantage. And, you know, Caterpillar puts a major emphasis on availability and our, you know, ability to keep the engines up and running. So, you know, through our robust engine designs, through the number of trained gas technicians and, you know, investment in the spare parts, you know, we are really involved in making sure our customers see high availability and see that extra revenue. I guess some things that you can do to maximize availability is first choose technology provider, you know, whether it's the genset or after treatment or pre-treatment, whatever it might be, that has demonstrated, you know, good durability on the type of gas that you have at your site, or just has a proven track record that way. Also, you want to make sure that you're applying the product properly. So if you have a higher efficient engine, you just want to make sure you're matching that with a cleaner biogas as well. Make sure you're within the guidelines by engine manufacturer for, you know, things like H2S and siloxanes. That's on the technology side. proper application, but it's also very important on the operation side. If the engine is, or genset is misapplied up front, you'll continue to see, you'll continue to have downtime and not be creating revenue. As I mentioned before, preventative and predictive maintenance is also is very important, just to make sure that good strategy is in place. Spare parts is also important. So what kind of spare parts do you have on hand at the distributor dealership, and then also what kind of spare parts are in country at the closest parts depot. It's good to understand that if something does go down, when will I get that part? And the same goes with service. Where are your service technicians coming from? And if there is an unplanned failure, because that's usually when availability is impacted the most, when will your service technician be there, and that kind of stuff. So all very important and part of a successful biogas project. So with that, concludes my portion of the presentation. If you do want more information on CAT product, you can visit catgaspower.com. I also encourage you to visit our YouTube page, where we have some customer testimonials and project highlights. And also you can contact the dealer at cat.com. All right, thank you.
Ben, thank you. Great presentation. Got a lot of questions queued up for you, so certainly be on the lookout for those. Now we'll turn our attention to Paul Owen from Cat Power Finance, and Paul is going to talk about the dollars and cents of making these particular projects work. Paul, looking forward to your presentation. Go ahead, sir.
Very good. I just want to make sure my presentation is showing up on the screen.
Looks great, Paul.
Okay, excellent. Well, good day, everyone. And Tim, first of all, I'd like to thank Biomass Magazine for allowing Cat Financial to participate in today's webinar to showcase our project lending expertise in the biogas sector. And as you said, my name is Paul Owen. I'm a relationship manager with Cat Financial in the Cat Power Finance group. Let's start with telling a little bit about who Cat Financial is. Cat Financial is a wholly owned subsidiary of Caterpillar, Inc. We are charged with helping support the sale of Caterpillar equipment globally. We're based in Nashville, Tennessee, have around 1,700 total employees, and a loan and lease portfolio in excess of $30 billion. Although the majority of Cat Financial's business consists of standard loans and leases to traditional Cat equipment, such as excavators and backhoes and the like, we do have specialized groups at Cat Financial to support the other products that Cat produces. I'm part of one of those specialized teams, Cat Power Finance, and more specifically the electric power generation team, or EPG. And the EPG team funds projects, not only the equipment component of the project, but the entire project that utilizes Caterpillar gensets and solar turbines. We have an experienced staff, including a lender's engineer on the team, several credit underwriters, documentation specialists, and several other team members that understand the markets that we serve, including the biogas markets. As you can see, we also focus on combined heat and power data centers, peak shaving, and the like. A large amount of the participants in the biogas sector may not have access to traditional corporate finance lending, which is based on a proven track record of credit quality, cash generation, and a strong balance sheet. And that's where Cat Financial comes into play. These projects rely on funding from equity investors, economic incentive programs, and project lenders like Cat Finance. Project financing does not lend against a company's balance sheet or previous credit quality. We rely solely on the cash flows that have not yet been generated to pay the debt. From a lender's perspective, project financing is considered substantially more risky than corporate or asset lending. So it's more costly and complex to get to the finish line on these projects. Some of the typical characteristics in project financing include higher risk items like establishing special purpose vehicles with a single asset that has a finite life, like a digester with a power plant associated with that. We also, project lenders typically, or we at Cat Finance certainly drive towards, if possible, not requiring recourse or guarantees from the project sponsors or equity providers. And as I said, which means that the debt must be fully repaid only from the future cash flows of a single operating asset. And the debt amount is usually substantially higher than the value of the standalone tangible assets in the project, which we will review shortly. In an attempt to mitigate some of these risks as a lender, you can expect to see lenders require sponsors to participate in the project by funding some of the upfront costs with cash and equity themselves. The lenders will take a first priority security interest in all of the project assets. That includes the hard assets that you can touch, the beautiful yellow machines that Ben talked about earlier, plus some of the assets that are soft, such as the construction agreements, revenue and supply contracts, and lenders typically look to establish cash control accounts to be able to control all of the revenue that comes into the project and distribute that according to a cash waterfall that has been agreed to, starting with the operation costs of the project, followed by debt repayments, maintenance, and distributions to the project participants. As I mentioned earlier, these projects, when we lend into them, typically we lend substantially more than what the project hard assets will support when you talk about a loan to value. So as part of the lending decision, we look at the cost of the project and take into consideration the entire cost. These include the hard assets such as the Cat gen sets or the solar turbine switch gear, the buildings or containers, tanks, separators, dryers, etc., but also include the soft costs that are required for a successful project to get off the ground, and that's for the cost of proper engineering, the permitting, interconnection costs, legal fees, construction costs during or construction financing costs during the construction period. Which leads me to talk about construction financing, which is where we provide the capital to construct the project with the expectation of having future cash flows to repay the debt. This is typically considered one of the higher risk stages of the project as cash is going out the door, and it's a long ways from an operating asset to repay the debt. When the construction is completed, we convert to a construction loan or a long-term loan and establish a repayment schedule at that time based off of the cash flows. So a typical project loan looks like an elongated bell curve with increasing debt during the construction period with the monthly draws to keep the construction and project timeline, and when that has reached substantial completion, the debt is established for the term and is repaid over time, as you can see in the gray area. Documentation for project financing is relatively complex because of the number of parties involved. The balancing act is to try to weave the documents together so that there's an adequate return for the project investors, but also provide satisfactory risk mitigation for the lenders into the project, specifically CAT Finance. So just to illustrate the contracts that the project and the lenders need to coordinate, I've created a simplified schematic that starts with the special purpose company in the middle that will own the asset or the biogas project, and then highlight the parties needed to create a successful EPG project. This includes the project sponsors with the equity holders, the tax equity or grants that are involved there, the off-takers for the revenue sources, which would include the power purchase agreement, RENs, RECs, the sale of the digestate if that's able to be sold into the soil amendment market. Obviously, the operator of who's going to operate and maintain the project, and in order to get the project built on budget and on time, the general contractor, the EPC contractor. And as you can see, there are several other parties involved in which documentation needs to be weaved together, and all these documents work together rather than in conflict for the project to be successful and financeable. Once sponsors or investors are prepared to engage into a discussion with a project lender such as CAT Finance, the expected progression towards funding is to start by providing preliminary information regarding the project, which includes who's involved, what the project is, a summary of cash flow information, and so forth. This is reviewed by the lender and potentially followed by a non-binding finance offer for the borrower to consider, and that non-binding offer puts into place or documents the expected term of the financing, what the cost may be to get it done, summary of the collateral that will be required, and repayment terms, the construction period, the costs, and sort of lays out what documents are going to be needed in order to do go to the next steps, which would include an in-depth credit review, followed by issuing a commitment letter, negotiating the documents, construct the project, and take out construction draws at that time. Once completed, convert it to the term loan, and obviously move into the repayment phase from the operating cash flows of the project. And so once if we negotiate or discuss the non-binding finance offer or indicative, and that is agreed by both parties and would like to move to the underwriting stage or the in-depth credit review, a lender will typically review a few items. They need to know, they need to understand who the borrower is, understand the project, the gas and feedstock supplies, and ultimately the cash generation expectations of the project. In order to determine this, the following information will be required from the borrower. Starting with who is the borrower, we would need an executive summary that reviews the project and sponsors the equity sources, a review of all of the partnership agreements and operating agreements and so forth for the credit underwriter to review in depth and understand exactly the interplay between the borrower, the sponsors, and so forth. Understanding the project itself, the technology related to the project, the how, who, what is going to be built. Much of this information is going to be reviewed by the project or the lender's engineer, and he's going to review specific information relating to the engineering, who has designed the project, what their reputation is, what the specific project documentation and schematics are. He's going to review the design, the EPC contractor, the strength of that EPC contractor, the contract itself to ensure that costs are controlled. And so as a project lender, we look for contracts that are either fixed price turnkey contracts or contracts that have a guaranteed maximum price. The engineer is also going to review the technology. We need to lend into proven technology. Serial number 1 is unfortunately not something that project lenders lend into. That's typically done by equity investors willing to take a risk on the technology. But we do have a substantial portfolio of digesters which we have funded into and are very comfortable with the most of the technology revolving around the digester business. And lastly, the engineer, along with the underwriting team, will review the operation and maintenance contracts to ensure that there is expertise to continue this project on a long-term basis. Feedstock and gas supply are obviously very critical issue or components to every biogas project. In order to mitigate the risk of not having guarantees or outside guarantees for these projects, and to ensure that long-term cash flows exist to repay the debt, long-term agreements need to be in place to have sufficient quantity, quality of feedstock with strong counterparties that have a proven ability to perform. The agreements need to be in place to cover the term of the contract and need to be coupled with technology and gas analysis reports that support the survival of the project on a long-term basis. Lastly, after understanding the project, the borrower, the technology, and so forth, it all comes down to cash flow and understanding that there is going to be enough cash flow to support the requirements for the equity investors to get their return and also have the ability to repay the debt that the project financier provides. So this is mainly based off of providing a financial model, and I'll say a robust financial model that is editable for the underwriters to be able to modify the assumptions for things like variability and uptime based off of our experience of doing similar projects, as far as how often these engines need to be serviced and issues that may be that we may run into. Have the ability to shock with cost and gas production changes and so forth, so that we understand the impacts of the cash flow if some things happen, and whether that would be able to suffice or to cover our debt, and as I said earlier, provide a suitable return for you as the investors into these projects. If a commitment letter, if after the credit review is done and a commitment letter is issued by the project lender or by Cat Finance, the borrower should expect to see some requirements in order to increase the probability of the cash flow projected in the financial models are met. They include things such as a fixed price EPC contract to control the costs, as I mentioned earlier, revenue and supply contracts on a long-term basis, typically with a tail of 2 years or so to the term of, longer than the term of the commitment. This allows for some wiggle room in case there are some cash flow issues along the way and the debt isn't repaid exactly as scheduled. All assets, again, hard and soft, of the borrower are provided as collateral, along with a pledge of shares which allows that in case of the unfortunate event of a default, it allows the lender to be able to take the project and market it or sell it as an ongoing business versus just the assets that are within the project, which have a substantially less value than a business that is able to continue on and produce some cash flow. The establishment of cash management accounts to address the cash that comes into the project, to distribute that cash according to an agreed upon waterfall, which is to distribute first to the operations of the project to make sure it's a continuing project. Secondly, to service debt and maintenance and whatever reserve accounts, and then lastly to release cash to the sponsors to as a return on their investment. Projects typically also have a debt service reserve, which is established up front of 6 months or more of principal and interest payments. Once again, as the projects have no other assets than what is involved for future cash flow, this provides some assurance that there will be some time to work out problems if there is cash flow comes a little bit slower than expected, or ramp up takes longer than typically modeled. And then there would also typically be a maintenance reserve account, which is funded out of operating cash flow, and those are not for unscheduled maintenance, but for scheduled maintenance, which can be very costly and lumpy into the cash flow of the project, and establishing a maintenance reserve out of the operating cash flows over time in advance of that scheduled maintenance ensures that the maintenance is done and the cash is there. And then obviously there, like most loan agreements, there would be some financial covenants in place to ensure that, or to monitor the cash operations. So those financial covenants would include things such as a debt service coverage ratio, minimal net worth, and the like. So I'll summarize with what is a bankable project. Some bankable projects include strong projected cash flow supported by long-term contracts, meaningful equity contributions by the sponsors, proven technology, and a solid construction and operational plan. If these things come together, it means a successful project for you as the sponsors and Cat Financial as the lender. If you'd like to contact me directly and discuss in more detail what project lending is and Cat Financial's experience in this market and what we do have to offer, feel free to contact me with the information that's on the screen now. And Tim, again, thank you for letting Cat Finance participate in today's webinar.
It's been our great pleasure, Paul. Thank you for your very thorough and comprehensive presentation. I know there's a lot of questions queued up for you as well. I see Ben is answering the questions that I have sent over his way, and we still have a very strong audience, and I'm sure everybody's looking forward to our final presentation this afternoon from Ross Buckingham. Ross is with California Bioenergy, and we're going to hear a story about how these things are deployed and how it works. Again, I'll be forwarding questions along, and definitely looking forward to some questions that I can ask in the Q&A session that I want everybody to stick around for. But without further ado, let's pass the presentation over to Ross Buckingham. Go ahead, sir. Ross, you want to check your audio? We've got no audio for you right now. Certainly see you. Let's make sure we get your audio.
Tim, sorry about that. And I probably...
good to go, sir. You're looking great, and we can hear you as well.
Good, thank you, and thank you for having me on the call this afternoon. California Bioenergy is a developer of biogas projects, and we're very pleased to have been able over the years to leverage both Caterpillar equipment that Ben talked about and also Caterpillar Finance to build, own, and operate our projects. So we have really been focused on building biogas projects since 2006. We, as a company, understanding the complexity of anaerobic digesters and building a biogas business, decided to focus exclusively on dairy and California, a combination of both a feedstock supply and an environment where we could get some reasonable economics. Our business model is to design, build, finance, and own with the dairy farmers our projects. And as we have found in the past, one of the most critical aspects of a biogas project is to have a really good control over your fuel or your organic material that's digested to make the fuel, and that creates an opportunity to really bring in our case, the dairy farmer as a partner in the project to ensure literally decades of access to manure. We provide additional revenue.
Ross, just very quickly, my apologies for the interruption. If you could just move the microphone just a skosh away from your mouth, we're getting just a little bit of some popping, and I think it's probably has to do with the distance of the receiver from your mouth. So again, sorry for the interruption.
No, I apologize. Hopefully that's better.
Sounds better,
yeah, we provide revenue to the dairy farmer. We produce an enhanced nutrient product from the manure after we've extracted the biogas, and we really focus hard on reducing the operational costs for the farmer by processing his waste in a different way. As a result of focusing, we've learned what it takes to be successful, and it really does take a multifaceted team. Our team has had to become experts in dairy and nutrient management, clearly project operations and maintenance, and a large aspect of our business is project management, financing, energy, environment, and policy factors. A little background on California and the reason why we focused here and have worked hard to build all the necessary expertise is that it is the largest dairy producing state in the nation. About 20% of the nation's milk comes from dairy. There's 1.8 million milking cows on 1,500 dairies, representing about 350 megawatts of potential biogas electric generation. And the majority of these dairies are located in the Central Valley. And furthermore, from the EPA map shown there, you can see that in just a few counties, there's some very intense concentrations of dairy farming, so access to feedstock is plentiful. These California dairies are also large and modern, and large is very important to us as a developer. As Ben mentioned, having a multi-megawatt facility is a lot more economical than having a few hundred kilowatt facility. In the last year, we brought 3 dairy biogas projects online. Our very first one was a small half-megawatt project where a lot of learning was done. These are covered lagoon digesters that receive the liquid manure from the dairy, collect the biogas, and run it through a genset for export to the grid. We've also experimented with tank digesters, and our second project involved deploying a large continuous stirred tank reactor supplied by MT Energy out of Germany, and on another small dairy. It was these 2 projects that allowed us as a company to understand all the pitfalls and challenges of getting projects built and online, looking at 2 different digester technologies and also 2 different engine technologies. This led to our third project, which is the largest dairy biogas project in California. It's a 2-megawatt facility, and it's where we took full advantage of CAT equipment and CAT finance to build, own, and operate that project. Just to give you a little feel of how large these projects are, this is a picture of a lagoon digester, just showing a portion or slice of the digester. The flexible cover has, in this case, been inflated with biogas. These things store several days' worth of fuel and are larger than 9 football fields in size for a typical 2-megawatt project. This is an example of a gas treatment station. This gas skid receives the biogas from the lagoon digester, strips the hydrogen sulfide out of it, dehumidifies it, and produces it into a good fuel for the engines. We deployed modular packaged Cat engine generator equipment. This picture shows 2 1-megawatt containerized gensets located on the side of the dairy farm. On the top of those containers, you can see the selective catalytic reduction system that scrubs the emissions for ultra-low NOx, which is required in California, and the urea tanks on the side. One of the things that we found, and it surprised us, was how complex these projects are. They may seem simple: build a digester, filter the gas, run your engines. But putting it all together from start to finish requires really a big team and a big team of trusted partners. It's taken us 6 or 7 years to put together our financial partners that include Cat Power Finance and our own sources of equity. As Paul mentioned, it's important to have skin in the game, and every one of our projects has California bioequity in the project. Our technology partners for the gensets and CHP, plus also our digester partners. Over the years, we've determined the best players by experimentation. And this is critically important to have good relationships here, because building that financial model, putting in the right gas assumptions, and building a pro forma is all a very important part of getting these projects financed, and trusting in the end product being a good cash flowing asset. We do get and require, and our own expertise allows us to get guarantees on gas production from the project as it's pulled together by our partners. The EPC partner that a developer has is important. They have to be experienced, they have to be cost effective, and they have to be willing to bond and guarantee the project cost. And it takes a while to get a good EPC partner on board. They have to trust the developer, and they have to trust the other partners. And we're very fortunate to have found Western Water to be our EPC partner in our projects. And then there's a handful of just experts, whether it be digester experts, engineering experts, nutrient management experts, GHG and climate experts. These are all needed to fill out the project. Obviously, the offtake relationships are critical, both for electricity, whether it be in our case the Sacramento Municipal Utility District, or PG&E, which operates the utility in the Central Valley where most of the dairies are located. It's also important to put together the other offtake agreements that are necessary to make the project work, whether that be greenhouse gas contracts for procuring offsets, and in our case we've done the same with SMUD and a PG&E program. This allows us as the developer to guarantee project performance, a very critical component to both raising equity and giving confidence to Cat Power Finance that the cash flows are going to be there to return to the equity holders their cash flow, and to term out the debt on its schedule. What have we learned? Well, after 6 or 7 years, we've learned it's hard, but there's some good and there's some bad and there's some ugly. And right now, the good stuff that we've learned is that being involved with large dairies is you're guaranteed to have feedstock. The manure is flowing on a regular, consistent, predictable, and reliable basis, and it happens every single day of the year. We've also managed to understand the anaerobic digestion technology and what works for dilute feedstocks supplies and how to build these large volume digesters cost effectively and economically. It's taken a while, but the permitting is always a challenge, and over time we've managed to figure out how to permit these with the Air District, the Water Board, and the county so that they can be predictably and reliably permitted to start construction and to get your authority not only to construct but your permission to operate within the schedule. The pitfalls that we've managed to work around have been that California dairy farmers for sure will not pay a tipping fee for the manure. It's already a valuable fertilizer for them, and when we contract to receive it and strip the methane out of it, we are not able to get paid for that processing. So that's a revenue stream that's not available in California for dairy projects. And also, even though the fertilizer value of the effluent is enhanced as it goes through the digestive process, the dairy farmers need all that fertilizer for their silage and their crops, and so it's not really possible for a developer to stream off that fertilizer and sell it as another co-product. So our projects have to rely on their electric generation and their greenhouse gas reductions. The other major pitfall we've found is that every job is custom. We try and get as much factory-built componentry onto the project, such as the packaged cat equipment, to make it faster and quicker and easier to deploy on the job. But we end up spending a lot of time on the dairy, and all our infrastructure and digester equipment is incremental to an existing dairy, so it's an expensive proposition. Digging holes on dairies there are construction risks that abound. Subgrade surprises. You often run into protected species and have to work around those. The utility and interconnect issues in California are pretty substantial. It takes a lot of expertise to manage through the PG&E interconnect process, for example. Also, it's very important to recognize that small distributed generation projects operating on biogas, usually remotely monitored and maybe with a part-time technician, do have operating costs that are probably higher than you'd normally expect. You've got your standard engine operating and maintenance costs, your hydrogen sulfide scrubber. You've got, in California for sure, you've got your ultra-low NOx selective catalytic reduction systems and ammonia that it takes to knock the NOx down. But then you have some other things. You have annual airborne tests, and they can be $15,000 or $20,000 for a full emission study. The interconnect facility has a monthly maintenance cost. These projects need to be wired for telecommunications, usually multiple lines for the various stakeholders. PG&E requires a couple of POTS lines and a T1. As an operator, you need wireless access. The meter reading and the billing system require operating expenses. Managing the PPA is an operating cost. And then in California, we have the CAISO, Resource Adequacy, Regis, the California Energy Commission, all require annual reporting and registration and documentation of energy production, etc. Property tax is surprisingly expensive on these projects. They do not get the solar project protection from property tax, so they're fully taxed at their constructed value. And usually insurance is also another very large expense. So it's very important as a developer to recognize all the expenses in the model to make sure you've got a self-sustaining project. And right now, these projects, they're still incurring fairly high financing costs, particularly the project equity, but that's starting to come down. All those are manageable with an experienced developer and good partners. The major pitfall that exists right now is that because of these expenses and because of the cost, a really good financial model requires a strong PPA. And by strong, I mean a good electricity price. And this is the biggest challenge these projects face right now. It's being addressed, and experience curve and scale is bringing the cost down. But right now, if you would have put together a pro forma on a dairy biogas project, you'd probably be looking at needing around 21 cents per kilowatt hour to make it all pencil, compared to maybe 10 cents or less for a solar project. And so that is a challenge in the marketplace to figure out how to make these biogas projects pencil. The issue is that the buyers of the electricity are unable to pay for any of the co-benefits of these projects, the cleaner air, the protected water table, and the other co-benefits have no value to the electricity buyer. And thus the pricing is for renewables is following the cheapest source, which is wind and solar. There are some very interesting developments where the time of day benefits of a schedulable and dispatchable dairy biogas facility is starting to become appreciated and valued as a way to deliver energy and shape the energy around the intermittent wind and solar renewable component. And that's an opportunity for dairy digesters to in fact get a more favorable and higher electricity price. Our experience in coming down the cost curve is significant over the last couple of years, and our plans and strategies going forward are to try and be competitive with solar as we build our scale. We'd like to see these projects pencil at around 10 cents per kilowatt hour. Right now, our most recent project is around the 21 cents per kilowatt hour. That's without subsidies or grants. The reason and way we've been able to build the projects in the past is by buying down some of the costs with state grant money and federal 1603 30% cash grant that was available for a few years prior to 2013. With experience and scale, dairy biogas can be competitive. And I think that's the goal, working with CAT equipment and CAT finance is to drive down the price of electricity from biogas projects to be competitive to solar, and to bring down the price and cost of biomethane to be closer to natural gas, and to build into the value proposition for a kilowatt hour generated from a biogas project to get the utilities to pay for the base load, reliable, non-intermittent nature of that power generation, the ability to deliver it during a time of day and shape it around the what's called in California the emerging duck curve at 3 or 4 in the afternoon when too much solar is coming onto the grid. We're looking forward to more robust greenhouse gas reduction market, and the California Climate Offset Program is starting to strengthen, and we're starting to see some better prices there, and we're also starting to see some long-term buyers for long-term contracts to deliver offsets. The air and water quality improvements and the farm nutrient improvements are other areas where project developers need to figure out ways to monetize those and bring that value into the projects. So with that, I'll wrap up and hand the call back to you, Tim. If anybody needs to contact California Bioenergy, we're easily findable on the internet.
Ross, terrific. Thank you. Great presentations all. I've got some questions queued up, and I certainly want to let folks know that I have every intention. Just want to make sure that we get the screen back to where we need it. I'm going to start with a relatively general question from Roger Blanton. Roger had a number of questions, and all of them very, very good. But the question that I wanted to ask that Roger poses is, and it was addressed to Paul, but I want really anybody that has an opinion or bearing on this to certainly weigh in. And Roger asked for Paul just for a general feeling from utilities for cooperation with developers of biogas projects. And Paul, why don't we start with you? What is the appetite out there from utilities when you're in conversations about these projects as they're being planned? How are those projects being received by the utility audience?
Well, I would say that I will be anxious to hear what Ross has to say in this aspect. I have found that it certainly depends on the area of the country or specific utilities. Some utilities certainly don't like the aspect of having what they consider a relatively small-scale project and the work that goes into the getting them connected to the grid and so forth. While I have had experience with other utilities outside of the state of California that appear to be very eager to work with the digester, anaerobic digester market to increase their renewables. So I would say it's very specific to the utility that you're dealing with, and sometimes even to the specific people within that utility.
Ross, if you want to pick up kind of your thoughts there.
Sure. I think the utilities are very much focused on procuring renewable electricity at the lowest possible cost. It's the way they're measured, and it's the way they're scored. And when they keep count of their kilowatt hours and their megawatt hours of renewables, it doesn't consider the source of that renewable energy. And as a result, the utilities in their renewable auction mechanisms or their procurement programs tend to be offering contracts at pricing for solar projects that is below where a biogas project needs to be at to be economical. So what we're finding is that the utilities need a bit of a push, and it usually comes from state legislatures who say that the greenhouse gas emissions are an important objective, the cleaning of the water, containment of the manures and the improvement in the water quality and air quality, and also we're also seeing some public utility commissions now pushing hard pushing the utilities to procure more dispatchable energy, and that's starting to change the equation a little bit. But it's still pretty hard to get a utility to pay a price for much higher than a wind project right now or a solar project.
Thank you both. I think I've got two more questions that I want to ask. The first question, and we received a number of questions in this category from Olaf Hansen and Donald Berry. Folks are wondering about the importance of co-products, whether it be liquid fertilizer, compost, solids for bedding back to dairy operations. Can each of you talk about the importance of co-products to the financials and even the operational side of the business? And whoever wants to start, go ahead.
This is Ross Buckingham from CalBio. I think I mentioned the importance of discovering co-products to help us make these projects economically viable at a lower and lower electricity price. And I think that has to be the goal, either through figuring out co-products that can deliver the electricity when needed as opposed to pushing it on the grid when it's not needed. The greenhouse gases offsets are obviously a co-product. The fertilizer has been a real challenge. In California, the vast quantities of flushed manure that are produced by these dairies is typically pumped out on the fields as a natural fertilizer, and it's very hard to do any concentration of that economically to get the nitrogen, phosphorus, and potassium to levels where it could be sold off the dairy. There appears to be some opportunity perhaps to use the waste heat from the CAT generators to offer a quicker processing of the separated manure fibers for a dairy farmer to dry them out quicker and to turn them into a more sanitized and less expensive bedding for the dairy cows. So there are opportunities like that we're looking at closely.
Paul, you want to take a shot at some
Sure.
of how important
I'll be happy to take
on the financial
a shot.
side? Yeah.
Is obviously the cost of building digesters is, as Ross has already indicated, substantially higher than other sources of renewable energy, whether that be in the solar market, landfill gas market, or others. And that necessitates the requirement to find other sources of revenue, from tipping fees, as Ross said, to be able to use the heat internally, or find ways to sell that heat or energy, to combine it with the revenues from the electric power generation, and then to increase the value of the digestate has proven to be a difficult task so far. I think it certainly is coming, but when it comes to being able to do that on a long-term and a regular, reliable source of revenue, it is a challenge, because much of the market is I'll say monopolized by a couple of large distributors throughout the U.S. A lot of digesters are in areas that sometimes are rural, and it requires a substantial amount of transportation costs. If you're talking about a dairy digester versus a organic diversion digester that may be in a more urban setting, and trying to convert that digestate into selling it to, I'll call it the big box stores, where they might brand it themselves and bag it and so forth. Those are certainly considerations to take into to increase the cash flows of the projects. But we have, as a project lender, we have had a difficult time counting that as a reliable revenue source. It certainly is a good source of increasing the return for the shareholders, but right now, there are some, as Ross also mentioned, in turning it into a truly high valuable product, it needs to be manipulated some with heating and drying, pelletizing, and the like, which adds additional cost. And so I'll say there are opportunities and opportunities to increase the value of the digesters themselves.
Terrific. Well, let's close with this one. A lot of questions like this. This particular version of the question was brought forward by Greg Moreland, and Greg's questions is, a lot of these, the presentations today focused on biogas to electric power. Makes sense, sponsored by CAT. But Greg's question is, are folks in your project pipeline increasingly looking at maybe splitting the gas stream, creating electric power with with one portion of that gas stream, but also generating like a compressed natural gas vehicle fuel product to capture some cellulosic RINs by producing a vehicle fuel? And I'll open it up to the floor there. Is that entering the discussion point, and are people looking at sort of producing two different energy products?
This is Paul. I can address some of that first, and see if Ross or Ben want to follow. And I would say the question in relation to whether RINs are driving some of the projects towards the vehicle fuel market is absolutely the case. I have had reviewed a few projects in which it's dual process of trying to produce electricity or a pipeline or vehicle fuel. And to this point, it's more of a theoretical discussion than anything else, because the few projects that I've reviewed and discussed is that essentially the digester gas that comes out of the pipe or out off the digester needs to be dedicated to one or the other for the markets to work very well. And so it's essentially building side-by-side digesters, some to go into the vehicle fuel market and the other for electricity. And the electricity prices are depressed in many areas around the country. And so we are seeing digesters look very seriously at the compressed or the gas or vehicle fuel markets.
Terrific, Paul. Anyone else want to add to that?
We're looking at California Bioenergy. We're looking very hard at hybrid systems that would combine the CHP for electric gen and utilize the heat and other resources to process some of the gas for other purposes, such as vehicle fuels. The attractiveness of the electricity is the 15 to 20-year PPA that underwrites the project financing, and the vehicle fuels market is still quite speculative and very difficult to get any sort of long-term financing. So it's definitely a large sort of equity bet in that direction. But I do think, in our analysis, the clustering of dairies with the collection of a portion of biogas from each dairy to a central location for a fueling station is potentially an outstanding idea, and we're looking at that pretty hard.
Terrific. Ben, do you want to add to that?
No, nothing to add. I think Ross summed it up very well.
Terrific. Well, then I'll close by, again, thanking Kat for sponsoring today's webinar. I'll thank all of you for joining us. And before I hang up, I want to direct everyone's attention to biomassconference.com. If you enjoy this type of content, if you enjoy biogas content, hearing from equipment providers, lenders, and people who have deployed these types of technologies, and you've never been to the International Biomass Conference and Expo, I strongly urge you to come. If you want to contribute, we are accepting presentation abstracts at this time through right around the holiday break. So go ahead and have a look at biomassconference.com. There is a $250 discount for registrations for folks that were on this webinar today. So if you know that you want to take it in, certainly pencil that webinar promo code down. And again, really, really great presentations, gentlemen. Thank you to Kat for sponsoring today's webinar. Thanks for all of you for joining us, and please keep your eye on biomassmagazine.com as we continue our webinar series moving forward into 2015. Have a fantastic afternoon, everybody. Thanks for being here. Thanks for reading. And thanks one more time to my presenters. Take care.